This is a production of Cornell University.
Okay, thank you. Thank you, Alan. Thank you, Don, for inviting me. It's a pleasure to be here. Hello, everybody. Hello, people in Geneva who are connected with us. So my talk is about terroir. So a lot of people think that terroir is a myth. So is it myth or reality? And we're going to try to give a definition of terroir, which is not easy because terroir is quite complex and there are many different factors dealing with terroir. And we're going to see that terroir is all about interactions between the vine and the environment, the vine and the climate, and the vine and the soil. And we can extract some key factors dealing with terroir and try how we can measure them and quantify them. Terroir also has a spatial component. Terroir is about origin, and origin has a boundary. And there can be variability. So spatial variability is very important when you're doing research on terroir. And once you know all this, well, then you will see that it's not so difficult to optimize terroir expression and manage terroir. So we're first going to look at if terroir is reality or myth. So there are quite a, I will just show a few statements on terroir that some people made. Some people think that terroir is a religion. You're either a believer or you're not. You cannot prove it. Another statement which you read very much in popular books about wine growing, not necessarily scientific books, but most popular books about wine growing state that terroir is about old vines extending deep roots into deep layers, and the vines pick up minerals from deeper layers, which by some mystery are transformed into aromas, and which gives the minerality to the wine. So wine grown on slate should smell like slate. That's another myth. Some growers, particularly in the New World, believe that terroir is protectionism from those who believe that they have, and of course those are the Old World growers, against those who are supposed to have not. Well, both are wrong. Old World producers are wrong to believe that they're the only ones to have terroir, because if terroir is about origin, a New World wine also have an origin. And New World producers, I believe that they are wrong, that terroir is just protectionism of European growers. Now the nicest one I've heard, and it was a very serious one, it is from an Australian researcher who's called Peter Dry. He's doing research on irrigation, that's why his name is Peter Dry. And in a conference something like 10 years ago, I asked him what he thought about terroir, and he said, well, terroir, that's just bullshit. Okay, so of course my purpose is to make you a believer, and so I take you to Burgundy to turn you into a believer. If you want to know if terroir is a reality or not, and I should have done this with Peter Dry, but I just hadn't the time to take him there, but one day I will. If you're not a believer in terroir, you just have to go to Burgundy. For historical reasons, in Burgundy, the growers own plots over different villages, different appellations, and different locations on the hill. And they basically grow all their vineyards in exactly the same way. They all have high density plantations, 10,000 vines per hectare, vertical shoot positioning, Pinot Noir for reds, Chardonnay for whites, same rootstock everywhere. And all the vineyards are trained in the same way. And they make the wine also in the same way. They just put the grapes into open top fermenter and punch down the skins with their feet, be it basic Burgundy or a Grand Cru. And then in the end, they turn out to have 10 or 12 or 15 different wines, ranging from €5 a bottle to tens of euros and sometimes hundreds of euros a bottle. And it's just because those blocks are located different parts of the slopes in different villages that the wines are so different. And then you go into the cellar and you taste these wines, and then you have to be a believer, because these wines are so different that there is something about the origin which makes the wine taste different depending on the place where it comes from. But of course this is not science, this is just experience. There are also a few examples from New World places where, without going into science, you can see that terroir is reality. And probably the first terroir wine from the New World was made in California, and it's called Martha's Vineyard. Maybe you know this wine. It's one of the top wines from Napa Valley. It is grown by the Heights family. And the Heights family, they made a very good Cabernet Sauvignon, and they had their own vineyard, and they were buying purchasing grapes from other growers, and they made a blend, a good Cabernet Sauvignon blend, which was quite famous in the late 1960s, early 1970s. And then they owned 2 blocks, and one was called Martha's Vineyard. And the winemaker every year said, well, the wine from this block is so good, it's a pity to blend it into the Cabernet Sauvignon blend. Why shouldn't we bottle it separately and sell it for a higher price? And of course, the salespeople were completely agreed. They said, this is great, because then we have a top wine and we limited number of bottles, and we can sell it for a higher price. And so they started to make wine from this particular block, and that's exactly what a terroir wine is: a specified origin with specific conditions of soil and climate. So Martha's Vineyard was the first wine, terroir wine from the New World. And when they made that, I don't know if it was whether it was in the late 60s or in the early 1970s. They didn't realize that they were making a terroir wine. And what is very often the case, which be it in the New World or in the Old World, if people make terroir wine, it's just to make more profit. Because if you make wine from specific locations and your wine is something special and you can sell it for a higher price, that's the good way to deal with terroir. So people make terroir wines just to make more money. And there was no science involved. There were no scientists going to Martha's Vineyard and tell the owners that it was something special. Science generally comes afterwards to explain why in some places the wine is different and the wine is better. And this, of course, I went on pilgrimage to Martha's Vineyard a few years ago, and I took this nice picture. Beautiful vineyard. So when terroir is reality, we should be able to make a definition of terroir. Now many people try to give a definition of terroir, but it's not easy. Because generally, if you try to make a definition of terroir based on one discipline, the definition is not very good. And a lot of people tried to make a definition from their own discipline. A geologist, I don't know if you know this book, Terroir, by a geologist, an American geologist who is called Wilson, James Wilson, and the book is very nice. It's about the geology of wine growing regions. There's just one thing which is wrong with this book, it's the title, because it's not about terroir, it's about geology. And geographers also tried to define terroir based on geomorphology, be it the slopes or that make what's special in wine. Soil scientists drew up very nice soil maps and then called it terroir maps, but those are soil maps, those are not terroir maps. Climatologists try to define climate zones for growing specific wine types and try to define terroir from a climatologist's point of view, but they talk about climatology and not about terroir. There's a famous French soil microbiologist, which is called Claude Bourguignon, and he thinks he deals with terroir, but in fact he's studying soil microbiology and not terroir. And well, there's nothing wrong with all these approaches, but they are not really about terroir. They're dealing with some specific factors dealing with terroir. And in fact, the most important thing these people forget is that the vine should always be in the center of a terroir study. You cannot explain terroir just by geology or soil types or soil microbiology or climatic zones. You have to integrate the vine and see how the vine interacts with the environment. And a few years ago I assisted to a conference, and there was a geographer from New Zealand speaking, Warren Moran, and he had a statement which I liked very, very much. He said, "We are all victims of our own discipline," and all these guys, they are a little bit victim of their own discipline. And terroir is pluri-disciplinary. A definition I liked very much about terroir is a very simple one. Terroir is a sense of place. I don't remember where I heard that, but I like it very much. If you taste the wine and there is something special about that place, then it's a terroir wine. A more complete definition was given by Professor Seguin from Bordeaux, who was probably the first one in the world to study seriously terroir on a scientific basis. And he defined terroir as an interactive cultivated ecosystem in a given place, including climate, soil, and the vine. And I like very much the idea of an ecosystem. An ecosystem is living beings interacting with their environment, and in our situation, it's the vine interacting with its environment. And of course, human factors are involved because it's not a natural system; it's a cultivated system. So man takes management choices which impact, of course, on the final result. And so the human factor is also very important. And this human factor has an historical dimension because generally people figured out what are the right varieties in their climatic situation, on their soils, which are the right rootstocks, which are the right training systems by trial and error. So sometimes old wine-growing regions can have some advantage in terms of terroir, not because they have more terroir, but they have a little bit more experience in managing their terroir. Science generally explains terroir, but only afterwards. It's very rare that scientists go into the field and say you should plant vines there because there's something special in the soil and the climate that will make a great terroir wine. Where science also can help is to optimize terroir expression. Once you know all the factors that are important in terroir expression, then science can help to optimize the terroir expression by specific management practices, and we will talk about that. So as I told you, that terroir is about interactions, and we can extract among all these interactions some which are more important than others in the final result. For this talk, I extracted 3 which I think are really sort of pillars in terroir expression. The first one is the timing of phenology, which depends on the climate. Of course, the warmer the climate, the earlier the phenology, but it depends also on your soil type. You can have warm soils or cool soils, and on the vine, in particular on the grapevine variety. A second pillar in terroir expression is water status. And in water status is about the interaction between the vine and the climate, rainfall, evapotranspiration, but also between the vine and the soil. And among minerals that the vines are picking up from the soil, nitrogen is probably the most important one because it affects very much vigor and yield and also compounds in grapes. So first let's have a look at the timing of phenology. When you try to, it's obvious that climate is an important factor in terroir expression. But if you try to define the ideal climate for grape growing, it's just impossible. We cannot give the optimum temperature range or the optimum amount of rainfall to grow a high quality wine. Simply, if you look at where great wines are grown in the world, they are grown at different places with different climatic conditions. Great wines are obviously made in Bordeaux, but also in Burgundy, where the climate is much cooler, and also in California, where the climate is much warmer. So there does not seem to be an optimum temperature range for growing high quality wines. So if you look at the climate alone, it's impossible to define the ideal climate conditions for growing great wines. And in fact, what's important is the interactions between the climate and the grapevine. So once again, we have to put the grapevine back in the center of the system. This is a statement made by 2 famous Bordeaux enologists, which were the directors of the Faculty of Enology in the 1950s and 1960s in Bordeaux, and these people can be considered as the founders of the enology school of Bordeaux, Jean Ribeiro-Gaillon and Émile Pénaud. And in their handbook about enology, I extracted this sentence. They wrote in the 1960s that in a given region, the best wines are obtained from fine grapevine varieties that just achieve full ripeness under the local climatic conditions, as if a quick ripening would burn the flavors that account for the finesse of great wines. Now, if you translate that in a little bit more modern language, you can say that, of course, to make high-quality wines, grapes must attain full ripeness. That's easy to understand. You cannot make great wines with unripened grapes. You would have green flavors, too much acidity, and too low sugar in the grapes. But on the other hand, it's very important also to consider that grapes should not ripen too early in the season. Because if you ripen the fruit very quickly in warm conditions, say for instance in July or in August, then it's just like growing tomatoes in greenhouses. There will be no flavor. There will be a lot of sugar. The wines will be lacking acid, so the grapes will be lacking acid, so the wines will lack freshness. But particularly there will be very little aromas. You get much more aromas if the end of the ripening is happening at the end of the season in cool conditions. So the timing of the ripeness is very, very important in terroir expression. Should not be too early, neither too late in the season. And on the northern hemisphere, more or less the right window for ripening grapes is between the 10th of September and the 10th of October. If you're after that, there's a big risk that your grapes will never ripen and you will have green flavor in your wine. If you ripen much earlier, say in August, then your grapes would ripen very quickly and your grapes would lack aromas. So that ripening window is very important. Now, if you look at European appellations, in European appellations, people defined the grapevine varieties they can grow. If you are in Bordeaux, you cannot grow any grapevine variety. You are restricted to a list of 7 or 8 varieties. And when you go to Burgundy, it's even more restricted. If you go to Tuscany, it's also restricted. And why are these varieties so restricted? Just because by trial and error, people have figured out which varieties in their condition ripen in the right temperature window. And that makes that in Europe, harvest is always between the 10th of September and the 10th of October. Whether you go to the Moselle, to Alsace, to Burgundy, to Bordeaux, to La Rioja, to Tuscany, up south to Alicante, where they grow a very late ripening variety, which is called Monastrell. Harvest is always in that right ripening window. If you grow Pinot Noir in Bordeaux, then Bordeaux is no longer a great terroir because Pinot Noir would ripen in August. If you grow Cabernet Sauvignon in Burgundy, Burgundy is no longer a great terroir because your Cabernet Sauvignon will never ripen. So that adequation between the timing of your variety and your climatic conditions is very important to grow terroir wines. Now, of course, not all wines in the world are terroir wines. People can also make varietal wines and not dealing with the origin, but focusing on the grapevine variety. And that generally happens when people are planting grapes in new wine growing regions where they don't have a lot of experience. They say, okay, we like Burgundy wines, white Burgundies are made with Chardonnay, so let's plant Chardonnay. But they don't look at the climatic conditions, if they are similar to Burgundy, and if Chardonnay is the right choice. And in many new wine growing regions, people plant rather early ripening varieties in warm conditions. This is the case in the south of Australia, was the case in California, in Napa, when they replanted a lot in the 1970s. They planted a lot of Chardonnay. And then the Chardonnay will ripen in those regions or Pinot Noir or Chardonnay, it will ripen in August. And then the grapes lack flavor. You still can make good wine, but then you need a lot of technology. If you ferment these Chardonnay in oak barrels, you let them age on the lees, you make a malolactic fermentation, have some nice diacetyl produced by the malolactic fermentation, then you get flavor in your wine. But it's not the flavor from the Chardonnay grapes, it's the flavor from a technological transformation. And then you're no longer making terroir wines, you're making wines more based on technology, which can be sound wines, good wines, but they are not terroir wines. If you really want to have a Chardonnay, a terroir wine from Chardonnay, go to Chablis. In Chablis is a very cool climate, and Chardonnay is really at the limit of its ripening condition. The Chardonnay ripens in the last days of September or early October, and then you have a lot of aromas from Chardonnay in your Chablis wine. For Sauvignon Blanc, for instance, if you pick up a Chardonnay from South Australia, which ripens in February, then you get no Chardonnay flavor in your grapes. So you need to oak it very much and have a malolactic fermentation to get aromas in your wine. If you go to Marlborough, where Chardonnay ripens very late in the season, in April, and sometimes even early May, which corresponds to early November in the northern hemisphere, then you have a lot of aromas from Sauvignon Blanc in your wine. So it's very important to be on the limit of your ripening conditions to make terroir wines. So to optimize terroir expression, if the climate is warm, choose late ripening varieties, and in Napa they understood. When they had phylloxera in the 1990s, they pulled up all their Chardonnay and replaced it by Cabernet Sauvignon. And Cabernet Sauvignon is ripening in Napa at the end of September or early October, so you can make a terroir wine with Cabernet Sauvignon in Napa, but you cannot make a terroir wine from Cabernet Sauvignon. You can make a terroir wine in Napa, but not with Chardonnay. Or if you want to grow early ripening varieties, and there are many nice flavored varieties among the early ripening varieties, and you have to look for cool climate sites like Carneros, which is closer to the bay from San Francisco. Climate is much cooler, and there you get aromas in your Pinot Noir and in your Chardonnay. I already gave the example of Sauvignon Blanc from Marlborough. For Pinot Noir, there's a very nice place in New Zealand, which is Central Otago. You see the snow on the mountains, very cool conditions, and they make great Pinot Noir with a lot of flavor. So that's about the timing of phenology. So that's the first point, which is very important. Second point, which is important to make wines expressing terroir, is the water status. And in fact, if you look at all the great wines produced around the world, and particularly for red wines, the best wines are always made under water deficit. So water deficit is very important. Now what happens when vines meet water deficit? You probably all know these. The shoot growth stops early in the season. So if you look at this slide, here you have the water potentials. So you go to the left side, the lower the water potential, so the more water deficit. And here you have the day of the year that the shoots stop growing. There's a quite good correlation between the day the shoots stop growing and the water deficit. The more water deficit, the earlier the shoots stop growing. Now you have the same sort of correlation for berry size. Here's the correlation between water potentials and berry weight, and you get small berries when vines are grown under water deficit conditions. You get lower malic acid, which simply means that your grapes are ripener. Very good correlation between water deficit and malic acid in the grapes. And you get the opposite correlation with anthocyanins. The more water deficit, the higher the anthocyanins in your grapes. Now you know all that if you want to grow high quality reds, then you need shoot growth cessation around or before veraison, small berries, low malic acid, and high anthocyanins. So that means that to grow high quality reds, you need water deficit, which does not mean severe stress, of course. Now, vine water status depend on climate, rainfall, potential evapotranspiration, the soil water holding capacity. On the vine, some rootstocks are more resistant to drought than others. The variety, some varieties are more resistant to drought than others. And on management practices. Leaf area, the bigger your leaf area, the more transpiration. Crop load, vineyard floor management. You can create competition for water between cover crop and the vine. And of course, if your conditions are too dry, you can irrigate. So water is important. Third pillar of terroir expression are soil minerals, but in fact, most of the minerals the vines pick up from the soil have not a decisive effect on the composition of the grapes. Strangely enough, one could imagine that iron or potassium or magnesium or calcium or whatever would have a big impact on grape composition. And in fact, many studies have been carried out, and these minerals only have marginal effect on grape composition, except situations of clear excess and severe deficiency. Of course, those extremes are never good. But when you are in a reasonable range for these minerals, the impact on the composition of the grapes and the quality of the wine is not decisive. There's one exception, that's nitrogen. Nitrogen really has a big impact on vine vigor, on shoot growth, and on grape composition. So this is some results from a trial we carried out also some time ago at Château Leeuwen, which is one of the most famous estates from Bordeaux. And we had a network of plots, and I only showed results from 3 blocks at Leeuwen to study why some blocks produce better wines than others. Now, in many situations where we measured the impact of the soil on the quality of the quality potential of the grapes and the quality of the wines, it turned out that water was the decisive factor. Now, it happened to be that we were at Leeuwen in 1997, which was a very rainy vintage. So in this rainy vintage, there was no water deficit whatsoever on any of the blocks because it rained all the time. But there were big variations. We noticed there were big variations in nitrogen status just because of different composition of the soil. Some blocks were very low in nitrogen, some were medium high, and some were high. And this is yeast available nitrogen, which responds very well to the amount of nitrogen that's available in the soil. And what we noticed that if nitrogen was low, which was the case for this block, that pruning weight was lower, yield was lower, berry weight was smaller, acidity was lower, and there was more sugar, more anthocyanins, and the ratings for the wine, we made wine by microvinifications, and in fact, with the low nitrogen in the grapes, the quality was better. And once again, low nitrogen does not mean severe deficiency. Of course, severe nitrogen deficiency is not good. But for growing red wine, it's better to be a little bit on the lower end of nitrogen status than on the high end. This will reduce your vigor. And particularly in wet conditions where water is not limiting, the nitrogen can be another limiting factor which slows your shoot growth, which reduces berry size, reduces vigor, reduces yields, and promotes the production of anthocyanins and tannins in your grapes. This is for reds. For whites it's a little bit different, because to make white wine you don't want tannins in your grapes, you want aromas. And many aroma compounds respond positively to nitrogen, which is particularly the case for volatile thiols, which are involved in the aroma of many varieties like Sauvignon Blanc, Riesling, Semillon. And so we studied the precursors of volatile thiols in grapes under low nitrogen conditions and conditions where we added nitrogen, and all these precursors were very much boosted by nitrogen. The tannins were reduced. This is exactly the same response as in reds, but the difference between reds and whites, that in reds you want tannins, and in whites you do not want tannins. So in whites it's better to be a little bit on the high side with nitrogen, which does not mean excess, because if you have really excess of nitrogen it will promote botrytis, which is not good in reds and not good in whites. So timing of phenology, water and nitrogen are essential factors in terroir expression. Now, how can we measure these? So the timing of phenology depends very much on climatic conditions. So it's good to have a good insight in climatic conditions on your estate. Well, climate is very easy to measure. You just put down a weather station. You can measure temperatures, which will be a driving factor for phenology. You can measure the rainfall, which have an impact on the water status of your vines. And you can measure potential evapotranspiration, which is when you make a water balance, potential evapotranspiration has as much impact on the final result as has rainfall. And generally people forget about evapotranspiration. If they compare climatic situations, generally people compare rainfall. They say, oh, in this area we have so much rainfall, in this area so much. But it's also important to take into account potential evapotranspiration. Solar radiation is also important for photosynthesis, and particularly for color accumulation. Phenology. So I told you that the timing of phenology is very important to grow high quality grapes. Now, of course, you can go into the field and measure phenology, but you can also predict it by phenological models. And these phenological models can help you to choose the varieties which are most adapted to your local situation. So in most situations, people have figured out which are the right varieties in their climatic conditions by trial and error. And it happens every time. If people plant grapes in a new area, they will try dozens of variety, and then they will end up after 1 or 2 generations saying, oh, for this area, this is the right variety. But you can do it a little bit quicker. You can save time and money by using phenological models. Just because phenological models are often quite simple models, because the main driving factor in phenology is temperature. There are other factors involved, but the main factor is temperature, and temperature is easy to model. So phenology can be predicted with process-based models, and you use then temperature as input data. There are a few examples of very old models which are very much used in the industry. The Winkler model, which is a temperature sum base of 10 degrees centigrade. The Hügling model, which is slightly more complex, but not very complex either, which is very much used in Europe. We've done some research on phenology modeling because we thought that these existing models could be improved. Because when Winkler made his model, his temperature model, he used only phenology data from Davis, and he didn't have a computer. And Hügling was the same. When he made his model, he had mainly phenology data from the Colmar research station in Alsace. He was from Alsace, and he didn't have a computer because it was in the 1970s. And today, we believe that phenological models can be improved by using more data and by just using computational power. So when we started to think about a new phenological model, we started to collect phenology data. For 2 or 3 years, we just were collecting phenology data from different locations. And we managed to collect over 4,000 phenology observations from 123 location, 81 varieties, and spanning over 48 vintages. We collaborated with a phenology modeler. She's quite famous, Isabelle Schoen. She has several papers in Nature. And she made a phenology modeling platform. In this phenology modeling platform, you put your phenology data, you put your temperature data, and you can test the whole range of models and then fit your models with your data. We were also very careful about the quality of the metadata, and we only used phenology observations when we had the metadata from located at less than 5 kilometers from the plot and less than 100 meters in altitude, to be sure that the temperature data was representative for the site. And we created a model which we call grapevine flowering Varietal model. And to create this model, we tested several types of models, linear models or beta models, and we tested other models. And in fact, the result, I have no time to go into the details, but surprisingly the result was that the linear models gave results that were almost as good and sometimes even better than the more complex models. And of course, we chose the simple models because it's also very important to transfer these models to the industry. And the easier they are to use, the more chance you have to transfer them to the industry. So from this modeling came out that the best models were linear models. So we just had to fix the base temperature and the day from which you start counting your temperature sum. And surprisingly, for the base temperature, very low base temperatures turned out to be much better than the generally in existing phenology models. It was assumed that the base temperature for vines is 10 degrees centigrade. So these temperature summations take out 10 degrees. And in fact, we got better results from low temperature threshold, and we even chose a threshold of 0 degree Celsius, because just in terms of efficiency, and the closer the efficiency to 1, the better the model. Root mean squared error is the error of prediction in days, so 8 days. So if you see, the more we increase the base temperature, the worse the prediction. Now for the time we start to count the temperature sum, we tested several days, starting at the 1st of January or several days. And in fact, the best result was at day of the year 60. So the grapevine flowering Varietal model is a very simple model. It's a summation of daily average temperature that starts counting at the 1st of March on the northern hemisphere, day of the year 60, with a base temperature of 0 degree centigrade, which makes that it remains very easy to use. Of course, we had to prove that it was better than existing models, so we compared it to the growing degree model from Winkler, which starts to count at day 1, 1st of January, with a base temperature of 10 degrees centigrade. Now for flowering, there was not much difference. In terms of efficiency, these two models were very, very close. But for Varietal, the prediction with the GFV model is much better. In terms of efficiency, it's 0.72 compared to 0.14 for the Winkler model. And in terms of precision of prediction, the GFV model predicts Varietal with an error of 7 to 8 days, whereas the GDD model predicts it with an error of about 2 weeks. We validated, of course, the model on 20% of the data set, and we got very nice curves in terms for flowering or for Varietal. A little bit more scatter, of course, of Varietal. And this work was published in the Australian Journal of Grape and Vine Research, a paper published in 2011. Now the next step was to classify for precocity a large number of varieties, and we had data from approximately 100 varieties. So all these varieties were classified for flowering, so from early ripening varieties to late ripening varieties. So here you have simply the temperature sum calculated with the GFV model to predict flowering, and we did the same thing for Varietal. This work was published in Agriculture and Forest Metrology last year, and we are now working on ripening. And the next step is ripening. And also we have the error bars for the prediction, and of course for the major varieties we have very small error bars because we had a lot of data, and for more obscure varieties where sometimes we had only 3, 4 or 5 data points, the error bar can be quite substantial. So if we get more data, we can improve the prediction for the varieties in terms of limiting the error bars. How can we measure water status? Well, we'll go quite quickly because you're familiar with these techniques. I firmly believe that you should measure the water status of the vines on the vines and not in the soil. I started during my PhD measuring it in the soil, but I have no time to talk about that, but I think it's much more efficient to measure the water status straight on the vine than to measure it in the soil. And I started working with water potentials in 1990, and I still believe that it's a great tool for monitoring water status. It's not very popular among growers, just because you have to go into the field with your pressure chamber and do the measurement. Generally growers or vineyard managers, they prefer to stay in their office and look at the computer data, and up to now it's not yet possible to automate the water potential measurement, but maybe one day, Alan, it will be possible to monitor the water potential directly and have the data coming on your computer in your office. We've over the last 25 years we've accumulated a lot of data from water potential measurements, and today we focus on stem water potential. Pre-dawn leaf water potential is also very fine, but leaf water potential, there's too much influence of the climatic conditions and the particular position of the leaf. So we no longer use leaf water potential, we use either stem water potential or pre-dawn leaf water potential to assess the water status of the vine. And here you see curves of 3 different vintages in Bordeaux. We don't irrigate our vines, and you see that the water status of the vines can be very variable depending on the vintage. So if you have a dry vintage, 2005 was the driest vintage ever recorded in Bordeaux, and water potentials can go very deep down. These are stem water potentials going down to almost minus 2 megapascal in 2005, and the vines didn't die, they didn't crash, they even made very good wine. In 2007, which was a very wet vintage, stem water potentials remained in the range minus 0.6, minus 0.8 megapascal. In 2004 was a moderately dry vintage where water potentials dropped down to minus 1.2, minus 1.3 megapascal at the end of the season. You can also monitor the water status of the vine on different blocks in the same vintage. So this is in the 2005 vintage, 3 blocks, gravelly soil with low water holding capacity. This is where the water potential goes down very much. A sandy soil with water table, where the water potential does not go down too much because of the water table, and a clayey soil with moderate water deficit stress. And so a very fine tool to very precisely monitor the water status of the vines over the season. And of course, if you irrigate, it's also a very fine tool to monitor irrigation. And I think it's the best tool in the world to monitor irrigation in vines. But there is one drawback, is that you have to go in the field. And people don't like going into the field to do measurements because it's constraining. And also another limitation, which is a real limitation, is that you can only monitor a limited number of blocks. Whether you do pre-dawn leaf water potential or stem water potential, there's a limited time during the day that you can do the measurement. For pre-dawn, the 2 or 3 hours before dawn. In the stem water potential, it's in just after afternoon, in the early afternoon. And so, depending on the distance between your blocks, you can monitor 5, 6, 8, or maximum 10 blocks. You cannot monitor 50 blocks or 100 blocks with this technique. So, a couple of years ago, we were looking for a technique where it was possible to monitor the water status of the vines without being limited in the number of blocks that you could monitor. And we adapted the method to vines, which is based on discrimination of carbon isotopes in grapes. Now the principle of this technique is that ambient CO2, and we're talking about stable isotopes and not carbon-14, of course, not radioactive isotopes. Ambient CO2 contains 98.9% of carbon-12 and 1.1% of carbon-13. Now during photosynthesis, the enzymes involved in transforming CO2 into sugar, they prefer to pick up carbon-12. So in the sugar produced by photosynthesis, there's a bigger proportion of carbon-12 than there is in ambient CO2. But when vines meet water deficit stress, the stomata close, and then there's still CO2 in the leaf, and the enzymes start to pick up carbon-12, and when there's no more carbon-12, they have to pick up carbon-13. So the proportion of carbon-13 integrated in sugars by photosynthesis increases with stomatal closure. And in fact, it's completely proportional. The longer the stomata are closed, the more carbon-13 that will be integrated in grape sugar. Now the sugar. Now the sugar produced will end up in the grapes. So if at the end of the ripening period you pick up a sample of grape juice and send it to a specialized lab who are doing stable isotope analysis, and you measure the proportion of carbon-13, the more carbon-13 you have in your grape sugar, the greater the water deficit stress the vines faced during grape ripening. So it's an integrative tool to measure, let's say, the average water deficit stress experienced by the vines from veraison to ripeness. This ratio of carbon-13, carbon-12, which is called delta 13C, is expressed against the standard. And so those laboratories who do the analysis, they all have the same standard, and they compare the ratio with the standard. And so I have no time to go into details how this calculation is done, but just retain that if the result is minus 27, then it means that the stomata were open all the time and there was no water deficit. And if the result is minus 20, then the vines faced severe water deficit stress and the stomata were virtually closed all the time from veraison to ripeness. So this we published in 2002 in Journal of Experimental Botany. You're probably more familiar with water potentials. So here you have the translation from, for instance, stem water potential values with delta 13C. So here you see the range, and so minus 21 in water deficit would correspond to a stem water potential of minus 1.4 megapascal. So there are several advantages of this technique, that it's easy to measure. Of course, you need specialized equipment, but there are labs who are specialized in isotope analysis. You just send your grape juice and they make the analysis. It gives you an integrated measurement of the wine water status during the ripening period, and there's no more limitation in the number of plots you can sample. It's just the price you have to pay, which is about, depending on the number of samples, between $50 and $70 a sample. But there's no limitation in the number. If you have 100 blocks and you want to know the water status of your vines in 100 blocks, you can sample 100 grape samples and send them to the lab and have them analyzed. It's also a very nice tool to validate irrigation strategies afterwards. When people irrigate, if you want to do quality irrigation for producing quality grapes, then you should maintain water deficit, but moderate water deficit. But it's very difficult not to add too much water, but to add enough water. And it's very nice to have a tool that in the end you can say, okay, my irrigation strategy was okay. I managed to maintain moderate water deficit. Just at the end of the season, you pick up a sample. If you're in the minus 23, 24 range, then your irrigation was okay. If the result is minus 27, then you irrigated too much. And if the result is minus 21, then you did not irrigate enough. Of course, it is not a tool for day-to-day management. If you have your hand on the tap and you need to know if you should open the tap to water the vines or not, then this result, of course, is coming too late. And then so you can manage irrigation on a day-to-day basis with stem water potential, and you can validate your irrigation strategy afterwards with delta 13C measurements. So we started to do this in a terroir trial where we compared the effect of the soil, the climate, and the grapevine variety on grape composition and wine quality. And so we started to do these delta 13C measurements on grape sugar in 1997, and we were lucky to have 4 vintages, 1997, 98, 99, and 2000, with very contrasting climatic conditions. 98 was a very dry vintage, and on our network of blocks, the average delta 13C was minus 22. 2000 was a wet vintage, average delta 13C was minus 23. 99, 97 were wet vintages, minus 24. And there was a very good statistical separation from the vintages. Now, also for the soils, we had 3 soils in the network with different water holding capacity. A very dry, gravelly soil, where the average delta 13C was minus 22. A clay soil with moderate water holding capacity, minus 23. And a sandy soil with a water table within the reach of the roots, minus 24. So also with this technique, we managed to separate very well the water status of the vines depending on the soil. Now for the grapevine varieties, there was very little difference between Cabernet Sauvignon, Cabernet Franc, and Merlot, which are the 3 major varieties we are growing in Bordeaux. So that means that the grapevine variety had not a major effect on the water status of the vines. And the water status was, in our conditions without irrigation, mainly determined by the vintage, climatic conditions of the vintage, and the soil type. So that means that in terms of interpretation, whatever the variety, the thresholds are quite universal across a wide range of variety, which is of course very practical for the interpretation. Now, how to measure nitrogen status of the vines? It's very easy with plant-based indicators. So once again, I'm a believer of plant-based indicators rather than soil-based indicators. It's very difficult to get a good idea of nitrogen status of vines by doing measurements on soil samples, because in soil samples you basically analyze total nitrogen, which is very different than available nitrogen. So there are many organs on the vines where you can measure nitrogen content, and they all work pretty well for assessing the nitrogen status of the vine. In fact, assessing nitrogen status of the vine is very easy. Leaf blade analyzers work very well, petiole analyzers work very well, and what works very well also is the amount of nitrogen in your juice. If your nitrogen status is high, then there's a lot of nitrogen in the must. If your nitrogen status is low, then there's very little nitrogen in the must. So it's a very good organ to sample nitrogen. You can do it on canes. You can also look at the color of the leaf blades with a Minolta spot meter, which in fact measures the coloration of your leaves, work also very good. So all these indicators work very good. We use a lot of yeast available nitrogen because people will analyze it anyway, because they will analyze it to know if their juice will ferment. So it's very practical. With one measurement, you know if your juice will ferment, and for the vineyard manager, he knows what is the nitrogen status of his vines. So we can measure, we can predict phenology, we can measure water status, and we can measure vine nitrogen status. But this assessment has to account for spatial variability, because it's very nice to know at one point what is the precocity of your phenology and what is your water status and what is your nitrogen status. But soils can be so variable that you're not sure that 50 meters further in your field that the water status and nitrogen status will be the same. So it's very important to account for that spatial variability. So how can this be done? For climate, a few weeks ago you had Benjamin Bois as a speaker, and Benjamin did his PhD in my lab, and we worked together on the assessment of the spatial variability of the climate inside the wine growing region. And of course, because we are in Bordeaux, we worked on data from Bordeaux, and we managed to identify 80 weather stations with at least 5 years of data. And based on the data from this 80 weather station, we created a spatial model for temperatures inside the Bordeaux area, which not only used the data from these weather stations, but also environmental variables like altitude, aspect, distance from water masses, distance from the sea, distance from the forest. Here is a big forest, and also distance from the town of Bordeaux, which is also a hotspot in the area. And so we managed to make a very refined mapping of temperatures all over Bordeaux, and it was different for minimum temperatures and for maximum temperatures. For instance, the Médoc is a hotspot for minimum temperatures, but not for maximum temperatures. Pessac-Léognan, south of Bordeaux, is cool for minimum temperatures, but warm for maximum temperatures. And Saint-Emilion, which is here, is warm for minimum temperatures and warm for maximum temperatures. So it's very nice to know this special variability, for instance, if you want to adapt grapevine varieties to your vineyard. And now in an ongoing research project, we're trying to do the same variable assessment of temperatures in a smaller region. And so this is the Saint-Emilion area, and we put temperature loggers on temperature sensors on vine posts with data loggers, and in 100 points in the area we measure temperatures. We just started, and we put these temperature sensors in 2011, so the first year of complete data was 2012, and already in 2012, if we compute the Hoogling index, we see there are quite some differences over this region. In fact, in such a small area as Saint-Emilion, Hoogling index ranges from almost 2,200 to almost 2,400, which is 200 degree days difference in such a small area, which is significant. But now still we have to figure out which are the environmental cofactors which are driving these temperature variables. So in fact we will use the same methodology as we use for the whole Bordeaux area with Benjamin Bois, but on a more refined scale. For phenology, once you know the temperatures are driving phenology, and once you know what is the spatial variability of your temperatures, then you can couple your temperature model with the phenology model, and then you can predict spatial variability of phenology. So this is a projection of veraison over the centimillion area, and you see that how veraison progresses over the area, August 8, August 9, August 10, August 11. So it takes about 1 week for veraison to be completed over the whole centimillion area. So we can predict spatial variability of phenology over a wine growing regions simply by coupling the temperature model with the phenology model. 5 minutes? Okay.
Some people may have to leave.
Okay, yeah. Feel free, if you have to leave, feel free. I will try to do this quickly as I can. Okay. So for spatial variability of wine of water status, you can use delta 13C. You can see here, this is part of the Cheval Blanc vineyard. You can see there's a very good correspondence between the soil type and the water deficit. They're ranging from minus 22 to minus 26. Nitrogen status, so you can use yeast available nitrogen if you take enough samples. And so here you have 10 samples per hectare. You can make very refined maps of the nitrogen status of the vine. So here you see the yeast available nitrogen ranges from 60 to 200 milligram per liter. And this gives you an exact idea of the variability of the nitrogen status over the estate, even with intra-block differences. Just the finer your grid of sampling, the more precise map you will make. So this is simply interpolating yeast available nitrogen data. And once you know all this, well, management to optimize terroir expression is very easy. You can use phenology models to choose the variety that will ripen in the right window in your climatic situation. Optimize the level of water deficit. If your situation is very dry, you can either use drought-resistant rootstocks or drought-resistant varieties. You can select soils with various soil water holding capacity, and if your climate is dry, then you can compensate by choosing soils with high soil water holding capacity. And in the opposite, if you are in a wet situation where the risk is that you don't have enough water deficit, you can choose a soil with low soil water holding capacity. You can do yield adjustments. If you find phase water deficit, they might be able to ripen 2 tons per acre, but not 3 or 4. And you can use irrigation if the situation is too dry. But with irrigation, you can only add water. You cannot withdraw water. And in many situations, people lose quality because they have too much water, not enough water deficit. I think worldwide, you will lose as much quality because of not enough water deficit than because of too much water deficit. To optimize the nitrogen status is even easier. You can, if it's too low, just fertilize, either by mineral or by organic fertilization. And if it's too high, you can use cover crop to compete for nitrogen with the vines. So, well, terroir is a reality. Just go to Burgundy, go to a cellar. Generally, you're very well received. You taste the wines from the barrels and ask from which block they come. And well, the vineyard management is the same. The winemaking techniques are the same. So if there are differences, it's just only because the plots are located in different situations. And the effect of climate and soil can be explained just by basic agronomy. You don't have to look for some mystery roots going very deep and minerals transforming into aromas. It's just about basic agronomy, about temperatures. Terroir is about temperatures, about phenology, about water status, and about nitrogen. These factors can easily be quantified, even with their spatial variability. And the output data from these measurements can be used to optimize terroir expression through adapted management strategies, be it the choice of the right variety, the right rootstock, the use of cover crop or not, the use of techniques to cope with your with your water status or whatsoever. Okay, so this was a very condensated talk. We are running in Bordeaux a course on terroir in March. So if you want to have the same stuff spread out over 1 week with more time for discussion, come to Bordeaux in March, and then we will have a little bit more time to discuss about all that. Thank you for your attention.
Yeah, so you mentioned climate phenology and variability, and you kind of convinced me terroir is a reality. What about the reality of climate change? You kind of tiptoed around that. I wonder to what extent you see the industry, for example, maybe thinking about using your phenology model to experiment with the idea of other varieties, exactly. Or what's happening with the industry in terms of their...
We do a lot of research now on climate change. I have no time to talk about it in my talk, but it's obvious that if the timing of phenology is so important in the terroir expression, that when temperatures are rising, the timing of phenology will be modified, and this will profoundly affect terroir expression, because the risk is that the varieties will move out of the ripening period, which is, for instance, already happening in Bordeaux with Sauvignon Blanc. Sauvignon Blanc is, for Bordeaux conditions, early ripening variety. In general harvest, Sauvignon Blancs in between the 7th of September and the 15th of September, and it's becoming more and more early. In warm vintages, we are harvesting Sauvignon Blanc at the end of August. We're definitely not making our best Sauvignon Blanc in those vintages. So one possible adaptation to climate change is simply to change the varieties. Now, to find possibilities of delaying variety, particularly for early ripening varieties, which can be either changing the variety or find any way to delay phenology. For instance, increase your trunk height or prune later, or using longer cycle rootstocks, and there are plenty of possibilities. But it's important to maintain the ripening in that right window. This can be very easily modeled, because with those phenology models, you can just add 1 degree or 2 degrees or 3 degrees. You can exactly see when it will happen if this or that variety will move out the ripening window. So these tools are very adapted to study the impact of climate change and to adapt the practices to maintain high quality production in your area. Another option is, of course, to move out of the area. But generally, growers don't want to move out of the area.
You just explained how that it was important to take in consideration the diversity of the water status of each region in the world. So what do you think? Do you think the water irrigation respect your definition of the terroir? You know what I mean?
For terroir expression, it's optimal. Okay. Yes. So the question was, is it possible to modify terroir expression by adapting your irrigation? Or is the question? So to optimize terroir expression, particularly for reds, for whites a little bit different. For making high quality reds, the ideal situation is a situation of moderate water deficit. And you can, my experience in Bordeaux is that you get quite far in terms of water deficit and still produce high quality wines. For those who are familiar with water potential measurements, in Bordeaux we consider it as quite optimal to have minus 1.3, minus 1.4, even minus 1.5 megapascal in stem water potential. And in pre-dawn we can go as down as much as minus 0.5, minus 0.6, minus 0.7 and still produce high quality wines. There is definitely, you have to take into account your yield. If your vines face quite severe water deficit stress, you can still produce very high quality with moderate yield, but you cannot combine severe water deficit stress with high yield, because it's very easy to understand. Water deficit will impact photosynthesis. If photosynthesis is limited, your vines are no longer able to ripen the free crop. So it depends also on your target in terms of crops. If your target is around 2 tons per acre, then you can go quite far in terms of water deficit. Now, of course, irrigation will modify the water status of your vines. So it depends on where you are naturally without irrigation in terms of water deficit. If there are two risks: to have not enough water deficit or to have too much water stress. If your risk is that you have not enough water deficit, which is in fact the case in many, many wine growing regions around the world, the point is that people are not aware about it. Because if you have not enough water deficit to grow high quality grapes, your vines are looking very nice. They are green, they produce, and then in the end the result is disappointing. But people do not connect it necessarily to the problem of not enough water deficit. If you have too much water deficit, it's very easy to see it, and your vines will defoliate, the grapes will shrivel, it will be away. Of course, if the risk is that you have too much water deficit stress, then irrigation is an option, because you can bring your vines back into the right window of water deficit stress. But if you have not enough water deficit stress, then irrigation is not an option.
I have a question from Geneva.
Yeah, we have a question from Geneva. We're going to have to wrap it up fairly soon. Good question.
So the question from Geneva, Mark Goldberger, do the white wines show the same relation to water deficit as the red wines?
No, so definitely you need less water deficit for whites than for reds, because water deficit is very important to have phenolics in your grapes. And for red wine, you definitely need phenolics. It's very difficult to have grapes with high levels of phenolics without water deficit. But for whites, you're more focusing on aroma compounds, and you don't want too much phenolics in your grapes. So definitely you should grow white grapes with less water deficit than red grapes. And this can also be a very interesting tool to optimize the terroir expression in your vineyard. Because generally in an estate, you have deep soils with high soil water holding capacity and shallow soils with low water holding capacity. Now if you plant your reds on your shallow soils and your whites on your deep soils, then you naturally will have less water deficit on your whites and more water deficit on your reds. So it's a very interesting way to optimize terroir expression. But many people are doing in Bordeaux. They grow their whites in their deep soils with more water, and their reds on the gravelly soils or the shallow soils.
I think a very typical reason why our whites do really well here in our deep soils with a lot of water holding capacity, and it's much more of a struggle with reds. Okay, I've been told we need to move on, so unfortunately we'll have to cut it off here, but if you have other questions, and again, thank you very much.
This has been a production of Cornell University, on the web at cornell.edu.